Hey everyone, it's Tim here, and we are back. We just set up our Circle 3D pipeline, or our graphics pipeline. So in our last video, we've set up this state. We're copying the example in the Circle app, and we've got a pipeline, some bindings, and a pass action, the render pass actions, and we've set that in a global state variable. And every frame we are beginning our render pass, we are setting the pass action to whatever we set in the init stage, and we're doing using our glue to swap chain. So swap chain, I believe, is I could be wrong, but I believe it's swapping sort of the buffers from our back buffer to our front buffers. So one of the actions when we set up a pipeline. Now, if we look at our init, we set up our environment for a start. We're using so-called glue to glue the GFX library to the app library, and then we're setting our actions. And our action is just a clear action, and we're setting it to this clear color. So we're basically just setting absolute basic clear color. And yeah, when we go make run, we've got this little app, and that's our background color. It actually matches the Mac background, but that's just a little bit of coincidence. Okay, so what we're going to do now is set up, we're going to do some shaders. So we're going to set up a shader. Now, the good thing, what SoCal allows you to do is write shaders in a general sort of shader language format, and it will compile them to multiple different sources. So if, like we are just at the moment, if you watch the setup videos, we're using Metal, we're on Mac, but this video could apply. You could be using OpenGL or DirectX or the WebGL, whatever you prefer. And you could set this up as cross-platform, but we're using Metal. So we could just go and write our shader in Metal and be done with it. But then obviously we lose all that cross-platform ability of it. And that's sort of half the point of using SoCal. So what we want to do is have a utility to compile our shaders to a cross-platform sort of in a cross-platform style. And SoCal, it's a little bit hard to find, but on the SoCal GitHub, if you scroll down to the little bit that talks about SoCal GFX, there's a little bit here that talks about shader dialect cross translation. Okay. Um, and yeah, this is this is now the official shader cross compiler solution. Okay, so we can click here for details. Okay, and this is it. It's called SoCal SHDC, which I'm assuming stands for Shader Compiler, would be my guess. Shader Code Generator for SoCal GFX. Okay. So you need to install this binary called SHDC. Okay, and now there is lots of ways to do that. You can compile it from source, and there is also some in the SoCal tools bin. There's another GitHub repo that has a pre-compiled binary. So if you prefer to build it from source, go ahead, follow the instructions. Else, come into this shader tools bin repo. I'll put all these links in the description. But if you go into the bin folder, there's your platform binaries. So I'm on OS X. I'm on an ARM, the latest. Yeah, and there it is, the SoCal SDCH binary. So download that, make sure it's in your path, in your bin folder, wherever you sort of put your bin folders. So for me, I have in my home directory, I have a bin folder, so I've just moved it into there. So pretty sure I've got a sys, yeah, SoCal. Okay, so you can see here, this is where I've installed my binary, and it sits there in my folder. So now I can just call this SoCal SHDC, and I've got my compiler there ready to go. Okay, so now we're going to let's create a shader, and yeah, let's do it. So in our source file, let's add a let's just call it yeah, let's just call it shader dot gl glsl, which is our shader language. Okay, so now there's some instructions on here to how to write our shaders. So we're going to just do the absolute sort of bare minimum example, really. It was a real simple one here. Yeah, this is it. So yeah, you can see standalone usage. This is how we're using the tool. So yeah, I think if you're using so Socol uses this FIPS build system, but we're using Makefile, so we're sort of ignoring all that. But if you were sort of following along with the FIPS build system, you could sort of include that into it. But we are just going to use a standalone usage. Okay. So yeah, this is our shader. So what we can do, we can have a vertex shader and a fragment shader. So we define the two shaders in the one file, source file, the GLSL, and it's using the GLSL source files, and then that will compile it to the different shader sources. So we're going to create a vertex shader. So let's yeah, I'm just going to put this in another window so I can just sort of copy it along, and as I type it out, and then we'll yeah, so in here we'll create a vertex shader, and I'll talk through it, and we're going to call our vertex shader VS. So this is, I believe this at symbol is custom to the Socol shader tool, and then the rest of it, now the dialect after this is actually the GSL, yeah, .glsl, which is the OpenGL shader language. Okay, I'm not a shader language expert by any means. So if someone, but I believe it's like, yeah, there's a particular version that's using. So if you read through it, it probably will explain it in a bit more detail. So yeah, so we can see here, this is our vertex shader. So we've got sort of the start of the vertex shader. We're called VS. We've just happened to call it VS. I believe you can name this whatever you want. And then this is the end. So everything in here is the vertex shader, and we're just using, yeah, the OpenGL GLS dialect. And so we've got an in variable, which is this position. So we're taking in a vector 4 as the position, and all we're doing is setting the GL position to that position. Okay, so it's really just a pass through. We're not really actually doing anything with it. And then we also have a fragment shader. Okay, so we have a fragment shader we're calling FS, and we'll end our fragment shader here. Okay, and in the fragment shader, we're going to have an out variable. So this is what we're going to be outputting, which is the frag color. Okay, and we create a main function. It's very similar to C, sort of like, and then we set our frag color. And in here, like what you would eventually do is pass through this color from the vertexes, but we're just going to absolutely set this color to, well, yeah, in this example, I'm just copying, is actually just set it to red. So you can see that one is red, one R, G, and then B, R green, red, green, blue. Okay. So, and then the last bit is the alpha color. So we're going to be full transparent, and we put a semicolon at the end. Okay. Now we've got a fragment shader, a vertex shader. Now we also just need to make a program. Okay. So we just call that program, we can call it whatever we want, but I'm just following the example. SHD is our name of the program, and in the program, we're going to include the vertex shader, and we're also going to include the fragment shader. Okay, and that is our shader. Okay, now we just need to compile it. So let's just have a go at compiling that without following the examples and see how we go. So we'll just run that. You can see we get an input path. Okay, so let's put our input to our input file, which was source shader, and let's also set our output. And let's put it to source shader GLSL, and maybe I believe it produced a dot header. So let's just run that and see what it does. Okay, no shader language, perfect. Okay, so we now to send this shader language. Okay, I hope you could see all that on the screen then. So let's go back to our thing here, shader language. So we can set, this is where we're going to output the different shader language. So we can set, you know, the versions of OpenGL shader language that you want to use, whether you're using Metal, etc., etc. So there is lots of documentation in here about the different, here it is here, all the different shader languages that you can set. So you can see OpenGL 4.1, 4.3, the web versions, DirectX versions, Metal, Metal iOS, and WebGL. Okay, so just you can actually set multiple languages at once. So I'm just going to use these ones here in this example, but like depending on the platform you're building for, just set this accordingly. I don't think you can set all of them at once, but you can set sort of a multiple one. So let's just set this. I think we just put a space, did we? Yeah, a little space there. So let's set that. And we've got an error. Okay. Undeclared identifier position. What have we done here? I think I spelled position wrong, have I? Missing an I in position. Okay, perfect. Let's update that. Let's rerun it. And flag color is an undeclared identifier. I'll put flag color. Okay. So we'll fix that as well. And compiled. Okay, let's have a look at our output now. So what that's done is generate this shader GSL file, as I've specified in the output, .h. Okay. So you can read through this, but it basically generates a source file, and this is the actual binary. So normally when you generate a shader, you need to compile it and then sort of include that, but this has actually included the compiled version as a binary number that's then just imported into as a header file. So we can just import this source file here, and we've got all our shader code there. And in comments, it sort of has the different dialects as it was compiled. So this is OpenGL version 4.3. So you can see and then this one's, this is, yeah, sorry. So we've got the vertex shader, and then we've got the fragment shader in OpenGL 4.3.0. And then this one is different. I'm not sure what this one is. Someone in the comments might be able to explain what all these different ones are. Oh yeah, this is the HLSL5 version, which I think was the DirectX. Did we ask for that? Oh yes, we did. We asked for that here. Okay. And we also asked for a metal version, so we should have a metal one in here as well. So yeah, here we go. So here's our metal. It's our metal shader. So we could just include our metal shader if we only wanted to write that, and we could just write this out by hand, but this compiler is basically written it all out by hand and then compiled it into this binary source here. Well, actually, I don't believe it's compiled. I believe this is the raw text of that comment, so it's not compiled yet. But once we pass into the shader, it will into the program, it will compile it. So yeah, right. Yeah. So yeah, there we go. So we've generated our shader. So in the next video, we'll have a go at including the shader into the pipeline. Okay, thank you.